Hello students, I hope that you are good, well and fine. In today's session, we will be learning about some particular functions integrations. Okay, so far we have seen the method of substitution and the method of integration using trigonometric identities, trigonometric formulas. Okay, now in today's session we will be learning about particular function integration directly. Okay, if you have something integration dx by x square minus a square form, then you will directly can get your answer. If you have this form dx by integration of dx by a square minus x square, if you have integration dx by x square plus a square, if you have dx by root of x square minus a square form, if you have dx by root of a square minus x square form, if you have dx by root of x square plus a square form, yes, if you have dx by some quadratic form in denominator plus dx by root of quadratic form, then in numerator you have some px plus qx and denominator some ax square plus bx plus c's form, and the last form will be px plus q dx divided by root of a square plus bx plus c form. So if you have any form among these, then you can easily give the direct answer to that expression or to that integration. Okay, clear? Okay, let us move next, and we'll be seeing, or we will be try to see that what will be your answer in such cases. So integration of dx by x square minus a square will be what? 1 by 2a log modulus of x minus a divided by x plus a plus some constant c. Okay, always add some constant. Okay, in indefinite integrals you have to always add some constant. Simple. Okay, now integration of dx divided by x square minus a square, this will be 1 by 2a log of x minus a divided by x plus a. Okay, if you clear what is happening? Okay, now in this integration what happened, what is different from the above? Just this, that the in the former expression we have x square minus a square, in this we are having a square minus x square, that's it. So this means this, if you memorize this, yeah, you can directly memorize this. How? What is the difference only? So this numerator term, so first of all replace the x and a terms. Okay, so this means you will have a minus x and a plus x. Okay, and as you can see, replace these also. Okay, interchange their positions also. So you will have in numerator a plus x and in denominator a minus x. So in this way you can easily memorize them. Clear? In this way you can easily memorize them without any problem. Okay, now what about 3? What is the difference? Now you are having the sum x square plus a square or a square plus x square. Then what will be your answer? In this form you will have 1 by a tan inverse x plus x by a plus c. Okay, clear? Okay. now what is happening? Now try to see that what in this, what about in this form? So dx is root of x square minus a square. The final answer will be what? Log of modulus of sine x plus root of x square minus a square, and for this sine inverse of x by a plus c. Okay, and for this it will be log of modulus of x root x square plus a square. Okay, clear? Always add some constant. Okay, let us move next. Now we'll see how we get to our answer in this case, the first expression. Now 1 by x square minus a square can be rewritten as in this form. You all know that x square minus a square can be reduced to x minus a, x plus a, the multiplication. Okay. Now further, this can be again reduced to in this form. This one, okay, this one can be rewritten as what? X plus a minus x minus a divided by 2a. Clear? Okay, so far so good. Now what? Now this can be further reduced to, or can be separated as 1 by x minus a minus 1 by x plus a. Okay, so far so good. Okay, so this integration is now in this form, and we know the integration of this. What is it? Log of modulus x minus a, and integration for this will be log of modulus x plus a, and log a minus log b. Log a minus log b is what? Log a minus log b is just nothing but log a divided by b. So we use log property here. So 1 by 2a log modulus x minus a divided by x plus a will be your final answer, plus c some constant. Okay, so that's why integration of this is equal to this. So whenever you see such forms, dx by x square minus a square, you will directly say that the integration will be 1 by 2a log x minus a divided by x plus a. Okay, I hope it is clear to you. Let us move next. Now proof for the second expression. What you will have? You can have, again we will be working on the same pattern, so try to reduce it. You will have 1 by 2a plus x plus a minus x divided by a plus x product a minus x. Now this can be further reduced to 1 by 2a 1 by a minus x plus 1 by 1 plus x. Now integration of this will be minus log a minus x. Integration for this will be minus log a minus x, and integration for this will be, as you can see, log modulus a plus x, this thing. Okay, now again using what property? Log property, that log a minus log b is just nothing, log a divided by b. So log a minus log b is equals to log a divided by b. Okay, so you will get this as your expression. Okay, so this integration and the just previous one integration is both kind of same, and their answer is also both kind of same. So make some pattern so that you can only have to memorize one. Okay, clear? So just memorizing only one you can answer, but you can answer both of the integrals form. Okay, clear? I hope it is clear to you. Let us move next. The third form proof. This will be, so here how you are going to prove that? Quite simple. We will use substitution method. Now put x is equals to a tan theta. Okay, if x a tan theta, then differentiate with respect to theta. So you will have dx by d theta is equals to a sec square theta. Dx will be a sec square theta d theta. Now what will happen? Now this dx can be replaced by a sec square theta d theta. As you can see, a sec square theta d theta. Now this x square can be replaced by a tan theta. This means x square will be a square tan square theta. We already have a square. Take what? A square common and a common from the denominator and numerator respectively. You will get what? Just 1 by a. So 1 by a. Now what terms you are left with? Let's see. You have in numerator sec square theta, in denominator after taking a square common you have 1 plus tan square theta, and you know very well that 1 plus tan square theta is just nothing but sec square theta. Yes, just sec square theta. So this sec square theta and this whole term will be get cancelled. So you only left with integration of 1 d theta, and this is what? Just theta. So theta by a plus some constant. Theta value will be tan inverse of x by a. So your final answer will be 1 by a multiplied tan inverse x by a plus some constant. Okay, I hope it is clear to you. So what we are doing is just nothing but substitution. We are applying substitution. X is equals to a tan theta. Dx is equals to, then dx can be replaced by a sec square theta d theta. Now x square further replaced by a tan theta, a square tan square theta, and now taking a square common from the denominator, you only left with tan square plus 1, and tan square plus 1 will be sec square theta. This gives you that sec square theta is already in numerator and as well as in the denominator. This means you can directly cancel it. Okay, and you only left with a by a square, and a by a square will be what? Just 1 by a. This means 1 by a integration of d theta. This means theta by a plus some constant. This means 1 by a tan inverse x by a plus some constant. I hope that you got this. Okay, let us move next. Now, this form, for this form, it is quite simple. Let x, so makes this substitution that x is equals to a sec theta. This means dx will be a sec theta tan theta d theta. Okay, so this dx will be now replaced by a sec theta tan theta d theta. Okay, put sec square as a square sec square theta, a square sec square theta. Taking a square common, what you will left with? Taking a square common, okay, you left with a square multiply with sec square theta minus 1, and sec square theta minus 1 will be just tan square theta. Now in root, what you are having a tan theta whole square. This means root can be removed easily. So yes, so in denominator you only left with a tan theta. Now this a and this tan theta will be cancelled because of the denominator. Okay, so you only left with what term? You only left with sec theta d theta term. That's it. So you left with this, and you know the integration of sec theta. So the direct integration for sec theta is log of sec theta plus tan theta plus some constant. Okay, clear? Plus some constant we are taking. I hope it is clear to you. Okay, so now what? Now theta, we have to replace theta in terms of x. So theta is just nothing sec inverse of x by a. Sec inverse of x by a. So sec inverse of x by a. So sec inverse of x by a, you only left with x by a. Tan sec inverse of x by a, you left with this form. How? Just replace this sec in form of tan. Okay, so replacing in form of tan, how? That you know that tan will be just nothing. Tan will be root of sec theta. Okay, root of sec theta. Sec theta is just root of sec theta square minus 1, this thing. So this is what we have used. Okay, direct form, just direct form. Clear? Okay, so you will get this. Now simplify it. What you will have? Log x plus root of x square minus a square divided by a. This means log some b by a form is there, some p by q form. This means log p by q form can be reduced to log p minus log q. So log p minus log q, log numerator minus log denominator. Okay, now this is some constant. this is also some constant. Okay, so I can give them a new name which is capital C. Okay, and this is what my another constant which can be taken out from where C1 minus log A. Okay, clear? Okay, so your integration of dx root of x square minus a square will be log of x plus root of x square minus a square plus some constant. I hope it is clear to you. Okay, let us move next. Now the fifth expression proof. So integration of dx of root a square minus x square. So this means x will be a sine theta. We will be using substitution x is equals to a sine theta. This means dx will be just nothing but a cos theta d theta. Now replace this dx by a cos theta d theta. We replaced. Now put x is equals to a sine theta. This means x square will be a square sine theta. Now take a square common. What you will left with? A square multiply with 1 minus sine square theta. This means a square multiply with cos square theta. This means root of a multiply cos theta whole square. This means you can directly remove the root. You left with in denominator you are having term a cos theta. Also in numerator you are having the same term. So this means you can directly cancel. Okay, this can directly be cancelled. This means the integration of d theta. This means theta plus some constant. Theta is what? A sine inverse x by a. So sine inverse x by a plus some constant will be the answer for this. Okay, I hope it is clear to you. So whenever you see this form integration dx root of a square minus x square, you will have sine inverse x by a. You will have sine inverse x by a. Simple. Okay, let us move next. Now what if we have a square plus x square? Then what? Now again substitution. What substitution can make a difference? X is equals to a tan theta. Okay, this means dx will be a sec square theta d theta. Now replace this dx as a sec square theta d theta. A sec square theta d theta. Now replace this x square by a square tan square theta, a square tan square theta. Now in numerator you will have root of a sec theta whole square, a sec theta whole square. This means this in numerator you will left with only a sec theta. So a will be cancelled and 1 sec theta, 1 sec will be cancelled from the numerator. So you only left with integration of sec theta d theta. This, and you know the direct integration for sec theta is log of modulus sec theta plus tan theta plus some constant. Okay, now replace sec theta in terms of what? In terms of x. So you are having tan theta is x by a. Tan theta is x by a means sec theta will be root of tan square plus 1. So this means x square. Okay, clear? So what I am doing is that I am replacing. So tan theta can be directly replaced by x by a. Yeah, so it is just x by a. But what about sec theta? Sec theta is tan square root of tan square plus 1. Root of tan square plus 1. Tan square is just what? X by a. So this means root of x by a whole square plus 1. This means this. Now simplified, you will have log of in numerator you have what? Log of numerator divided by some denominator. Okay, and you can break that thing into what property? That log of numerator minus log of denominator. So let's see what will be in our numerator and what we will be in our denominator. So in numerator you will have x plus root x square plus a square, and in denominator you will have a. That's why you will get minus log mod a. Okay, plus some constant, and this will be, I am naming it as another constant c, which is c1 minus. Okay, sorry. Okay, clear? I hope it is clear to you. Okay, so you will get this as your final answer. Okay, simple. So the what we are doing, we are just again and again using substitution in such forms. Okay, so the main thing, if you suppose if you do not remember or memorize these, so don't worry, you will have these, what your substitution, the main thing or the essence of these are just nothing but the substitution, that what substitution we are making, we are using. Okay, clear? Okay, let us move next. Now this expression, so to find this integral, what we do, we write a square ax square plus bx plus c as what form? First of all, we try to make complete square form. Okay, by taking a, the coefficient of x square as common, so you will have x square plus b by ax plus c by a. This means you can make now x plus b by a whole square plus c by a minus b square divided by 4a square, or b by 2a whole square. Okay, clear? Okay, this form. Now what you will do, you will put this as your t. Okay, putting this as your t, you will have dx by dt. Now you can directly replace dx by dt. Yes, you can directly replace your dx by dt. So this will be what? So this expression given can be reduced to a times of t square plus a times of taking this as some constant. Okay, as you can see, plus minus k square taking some constant. So you will have this form 1 by a integration of dt by t square plus minus some k square. Okay, depending upon the sign of this. Clear? Now you can directly use what form? This is what integration of a square plus x square, or x square minus a square form. Okay, you have already seen this form. Okay, either you will be using what? This form. Yes, as you can see, x square minus a square form, or this form, and you directly know about these form. Okay, so these steps are very easy. Take a common, then make it use the completing square method to form like this. Then put whatever you got here, it equals to t, then differentiate with respect to t. You will have this form. According to the sign of this, you will use either this or this. Okay, I hope it is clear to you. Simple. Okay, let us move next. Now, what if you have to find integration of 1 by root of ax square plus bx plus c? Okay, we'll use the same thing. We will use the same thing, but at the last step, what form you will have? You will have either this form, yes, or you will have either this form. The only difference, in the former expression you was getting this or this form. Okay, but in here you will get either this form or this form because of this root. I hope that it is clear to you and you know about the direct evaluation of these four. Okay, clear? So in order to get the answer for these two expressions, you must know about these integrations. Okay, I hope that it is clear to you. Let us move next. Now, what about this? So for this, what you have to do is simple. Okay, so first of all, what we are given is in numerator you are having px plus q, and in denominator you are having ax square plus bx plus c. Okay, where the coefficient p, q, the constant terms a, b, c all are some constants, real numbers. Okay, now this form can be easily reduced to what form? This px plus q can be reduced to a times of derivative of ax square plus bx plus c plus b, which is equals to a times 2ax plus b plus cap b. Okay, clear? Okay, let us move next. So now for this, the same we will be doing as we did. Okay, I hope that it is clear to you. Okay, clear? I hope it is clear to you. So that's it for now. If you are having difficulty in any of the forms, don't worry. Okay, when you will see the examples, when you will see or try the exercise question examples, you will get to know that what do we mean by these approaches, what do we mean by these steps. Okay, so for now this is it for the theory part. We'll be back with examples. Okay, and the exercise based on only this concept of some particular functions, integration of some particular functions. Okay, so thank you all